Hey, good morning, everybody. We're in section 5 here in AP Pre-Calc, and we're going to be going over some Pythagorean identities and applying more trig. So here we go. All right. The goal here is to use trigonometric identities to simplify expressions. And we want to simplify expressions and proof statements to develop understanding of the formulas and identities. Okay. All right. So what we're going to do is we're going to start off with our famous circle here. Our unit circle radius 1. So let's draw a little picture here. All right, so I'm gonna plot a point here, draw the radius r, call this point P, comma x, comma y, around the unit circle here. So actually, instead of radius r, let me call that 1 because we're on a radius unit circle with radius 1, so okay. Draw the little right triangle here. All right, and we gotta go x units to the right, y units up, and this little angle in here is called theta. Okay, so theta, so we know on the unit circle with radius 1 that sine of theta is y to r and cosine theta is x to r. So you'll see our basic definitions off to the left. Okay, these are already known and memorized, hopefully. And we know the Pythagorean relationship here, x squared plus y squared equals r squared, but in this case, we got a radius 1. Okay, so on this unit circle here, we got radius 1. So really what we have is it says r equals 1 because you have a unit circle here. We have x squared. So we have x squared plus y squared is equal to 1 squared or 1. Okay? I know it doesn't sound like a whole lot, but okay. Let's go on the left side real quick. So since we have a radius 1 here, what we have here is, let's take this over here, we have sine theta. It's typically y to r, but r is 1, as I said, so that's equal to y. Cosine theta, well, that's typically x to r, as you guys know, but r is 1, so we have x divided by 1, or x. So on this unit circle here, we have at point P, really we have cosine theta, comma, sine theta. And again, this is nothing new. All right, you guys know this. But what we can do is we can take these definitions here. All right, y equals sine theta, x equals cosine theta, things that we already know, sub into this formula here, which is called your Pythagorean theorem. All right, Pythagorean. All right, theorem. And, well, it's not the Pythagorean theorem exactly, but we're applying the Pythagorean theorem. That's what I meant to say. And what we're going to do is we're going to substitute sine theta in for y, cosine theta in for x, and see what happens. All right, so here we go. Starting with x here. X is cosine theta, so cosine theta squared plus sine theta squared. Again, y equals sine theta there. That's equal to 1. And when you square cosine theta, the way you write that is cosine squared theta. This is a quick way to write it without parentheses to make it look nice. And that's how it looks in decimals too, by the way. And then if you square sine theta, you write it as sine theta squared, and that equals 1. And this is called your Pythagorean identity. Okay, your main, most important identity. Identity meaning truth here. So call it the Pythagorean identity. Let's highlight this. This is equation 1. Now we're going to develop a lot of equations here, and each one gives us variations of the other ones. Okay, so what we're going to do is we're going to take this equation, all right, this identity right here, and we're going to divide it by a function to develop other identities. Aha. Okay, so we're going to call that, again, this is equation 1, our main Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. And by the way, this one right here, this one has to be memorized because this one develops everything else. Okay, so really commit that to memory. All right, we're going to use this one a lot in this section. So what we're going to do to develop the other guys, what I call variations of these guys, is we're going to divide the main identity, we're going to divide it by a function. Okay. All right, so what we're going to do, the first variation here, is we're going to divide equation 1, divide equation number 1, all right, by cosine squared theta. and watch what happens. Okay, so here we go. I'm going to take this right here. Here we go. I'm going to take each of the three terms here. There are only three terms, and divide them by cosine squared theta and see what happens. So cosine squared theta divided by cosine squared theta. Second term, sine squared theta divided by cosine squared theta is equal to 1 divided by cosine squared theta. Well, what do we get? Well, anything divided by itself is 1. Okay, sine squared theta divided by cosine squared theta. Well, that kind of sounds like, well, sine, we know that tangent theta is sine theta divided by cosine theta. We know that. So I'm going to put down we know. We know there. All right, so what happens is if you take that fraction, you square both of them, I'm talking about the numerator and denominator, you get tangent squared theta. And then here, if we know that 1 divided by cosine theta equals the reciprocal function secant theta, well, guess what? This is just secant theta squared. And that gives us our second equation. Okay, so we're going to label this equation number 2. Okay? So I took some things that we know and I applied them. Okay? Okay, there we go. Okay, so now what we're going to do, to get another variation, okay, so number 2, we're going to divide the main equation, our main Pythagorean identity here. All right, not by cosine squared theta now. We're going to get creative. We're going to divide it by sine squared theta. So, I meant equation number 1 here. So make sure you put that in there. And what do we get? Okay, so here we go again. So at this very top, I'm going to take my Pythagorean identity here and divide each of the three terms by sine squared theta this time. So in the Pythagorean identity at the top of the screen right here, first term is cosine squared theta. I'm going to divide each of those terms by sine squared theta and simplify it and see what happens. My second term is sine squared theta. As I just said, I need to divide all terms by sine squared theta. Even the right-hand side, I got to take 1 divided by sine squared theta and then simplify it. Well, what do we have? Well, we know, I'm going to put this over here off to the side. All right, we know that cotangent theta is equal to cosine theta divided by sine theta. We already know that from previous lessons. So if you have cosine squared theta divided by sine squared theta, well, guess what? That sounds like cotangent squared theta. That's the same thing. Here, sine squared theta divided by itself is 1, obviously. And then we get 1 over sine squared theta, excuse me. But you have to remember that, cosecant, oops, let me rewrite that. Okay, cosecant theta is nothing more than 1 over sine theta. So in that case, we get cosecant squared theta. And this is our third main identity. We're going to call this equation number 3. Okie dokie. Now we have variations of these, so we'll talk about that in a little bit. All right, so now, what do we have? Let me see. We got some variations. So I'll tell you what, let's take a look at some variations here, some more variations. Okay, more variations. Okay, here we go. So what we're going to do is we're going to take our main equation here. So I'm going to rewrite equation number 1 over here, which is our main Pythagorean identity. Cosine squared theta plus sine squared theta equals 1 right here. And believe it or not, you can get 2 variations off this. So if you isolate cosine squared theta, all you have to do is subtract sine squared theta. So one of the variations is cosine squared theta equals 1 minus sine squared theta. That's variation number 1 there. And guess what? That can be factored here, which we'll talk about in a minute. The other one, you isolate sine squared theta by subtracting the cosine squared theta. So the other variation is 1 minus cosine squared theta. And each of these is a difference of squares, which can be factored. Okay, so if you factor these guys, let me go off to the side here a little bit here. So let me refresh your memory on Algebra 1. This is called a difference of squares, and you saw this many years ago in Algebra 1, a squared minus b squared, and that gets factored as a plus b times a minus b. Okay, you saw these in Algebra 1 a lot. And so what we want to do is we want to take this difference of squares, because that's what we have, and we want to factor it into two binomials. Okay, so you get some variations here. So we're going to factor it as 1 minus sine theta times 1 plus sine theta. And the other one we're going to write as 1 minus cosine theta times 1 plus cosine theta. All right, that's right from Algebra 1. It's called a difference of squares. All right, what we just did right there, my friends, is we just factored. Okay, that's all we did. We just factor each. Okay, now the second equation at the top here, equation number 2, let me see, I wrote down 1 plus tangent squared theta is equal to secant squared theta. Now watch this. This variation, if I isolate tangent squared theta, okay, all you have to do is subtract 1. My variation of this is secant squared theta minus 1. And guess what? That's factorable. That's a difference of squares again. So I can factor this as secant theta minus 1 times secant theta plus 1. Okay? So there's my next variation. And my last variation, if I take equation number 3, which is, well, it's highlighted right there in red. Okay, it says cotangent squared theta, all right, plus 1 is equal to cosecant squared theta. Okay, what do I get if I isolated cotangent squared theta? Well, all you have to do is subtract 1 again. I mean, it's pretty simple, right? You just go minus 1 minus 1. So what do? Well, you have cotangent squared theta is equal to cosecant squared theta minus 1. But guess what? That is a difference of squares again. So this can be factored into two binomials as cosecant theta minus 1 times cosecant theta plus 1. Again, it's this famous difference of squares happening right here over and over again. It just happened 4 times in a row. So you really have to understand the basics of Algebra 1, all right, to understand this lesson, because that's all I'm doing is basic factoring, okay? Factor into two binomials. Okay, which you started to learn, again, when you were, 8th or 9th grader. Okay, so now, what do we have? So let's keep on going. All right, so let's do a little review here. We know these already. We've already studied these, so this is just a review. This is nothing new. So cosecant theta is 1 over sine theta. These are the reciprocal functions. Secant theta is 1 over cosine theta. And cotangent theta is the same thing as cosine theta divided by sine theta. Nothing new there. Okay, now we're going to go back to first semester here and remember something about even and odd functions. Ooh, okay, so this is taking us way back. What is the definition of an odd function? What's the definition of an even function? Okay, so if you're in class here, tell the person next to you, what's the definition of odd? What does it mean to be odd? Like, which of these graphs given is odd, and why? What does it mean geometrically? What does it mean visually and geometrically and algebraically? What does it mean to be odd? What does it mean to be even? Okay, so let's start off with the odd function here. Okay, so odd functions have symmetry about the origin. So I'm going to state that here. So these are symmetric, okay, about the origin. Okay, so you can see that the sine function here in red is an odd function here. And so when you're symmetric about the origin here, x comma y gets transformed to the opposite of x comma the opposite of y. And you'll see that right here. If you take a look at point A gets, if you rotate it 180 degrees about the origin right here, that's what we mean by symmetric about the origin. It gets rotated, all right, to a prime. So notice that pi halves comma 1 right here at point A goes to a prime at the opposite of pi halves comma opposite of 1. Notice that both coordinates change. All right, we call that odd. This is what it means to be odd. And we call that symmetric about the origin. Okay, because of that, the sine function here, the sine of x here, or sine of theta, has to be, or excuse me, it's not theta, talking about negative theta here. So if you take the opposite of theta, you get the negative sine theta. So let me rewrite this here. So if you take the opposite of theta, the input, which is called negative theta, all right, that's going to be equal to negative sine theta. So again, you take the opposite here of the input and you get the opposite of the output. That's why both coordinates change. Okay, and there's a little basic down here. Memorize the basics. All right, sine of negative theta equals negative sine theta. This is the definition of odd function. Okay, it's symmetric about the origin. Now, the cosine function, which you're looking at down here, cosine x, does not have that property. Okay, so notice we have a y-axis here, and notice that the max here at point A at 2 comma 1 gets reflected across the y-axis here to go to A prime. All right, it has y-axis symmetry. Y-axis symmetry here. And any function that has y-axis symmetry is called even, okay? So an even function has y-axis symmetry. Okay, and because of that, x comma y gets mapped to the opposite of x comma y. And because of that, we say that cosine of negative theta is the same thing as cosine theta. All right, whether you put 2 pi in or negative 2 pi in, look at that, you get 1. Okay, so the output, all right, does not change. So cosine negative theta equals cosine of theta. We call that an even function. Okay, so that's just integrating what we learned a long time ago with regular functions to trig functions, sine and cosine. All right, sine is odd, meaning it has origin symmetry or 180 degree rotational symmetry. And then the cosine function is an even function that has y-axis symmetry. All right, so because of that, watch this. If you know these two, if you know sine is odd and cosine is even, then you can figure out the rest of these. Watch this. All right, so tangent of negative theta is the same thing as negative sine theta divided by cosine of negative theta, right? And by the definitions that we just posed above, this is equal to negative sine theta divided by cosine theta, which is equivalent to negative tangent theta. Okay? So I know that tangent of negative theta equals negative tangent theta. Look at that. All right, which means tangent theta is odd. Okay, so this is an odd function. Okay, so let's look at the other one. So cosecant is a reciprocal of sine, so this is 1 divided by negative sine theta. Well, as I just talked about just a minute ago, that's 1 divided by negative sine theta, which is the negative of 1 over sine theta. which is negative cosecant theta, because 1 over sine is called cosecant, right? So guess what? The cosecant function's odd as well. Okay, so this one's odd too, because cosecant of negative theta equals negative cosecant theta. That's the definition of odd. Okay, now let's take a look at secant. Well, this is 1 over cosine of negative theta, but that's a 1 over cosine of just theta, cosine theta, which is your secant function, secant of theta. So I know that secant of negative theta equals secant theta. Well, that means the secant function is even as well. Okay, how about the cotangent function? Well, this is equal to the cotangent of negative theta divided by the sine of negative theta. If you simplify each, the top becomes cosine of theta by definition because it's even. This is negative sine theta because it's odd. And so you get negative cotangent theta. So that means that cotangent of negative theta is equal to negative cotangent theta. So that tells you that it's odd. Okay? Well, there you go. All right, now we know which of the functions are even odd and what kind of symmetry they have, even if we're not looking at the graphs. Look at that. Okay, so now let's simplify some expressions here. All right, so here we go. Let's apply this stuff. All right, so the first one is secant x minus sine x times tangent x. Okay, so the first basic skill you have to do is, okay, and let's write it off in the red over here, is you're going to rewrite, if I can, yeah. So rewrite, okay, all functions in terms of sine and cosine. So first basic skill, rewrite all functions, all right, in terms of sine and cosine. If you're going to simplify things, this is the first thing you do. All right, so here we go. I'm going to rewrite them all. Okay, secant x is 1 over cosine x. Okay, our input variable is x now, not theta. So just get used to variable switches because that happens all the time. Times sine x times tangent. Now tangent is sine x divided by cosine x. Okay, so step 1, you just rewrite in terms of sine and cosine. Now, what you do is you go ahead and multiply, right? So you have 1 over cosine x minus, well, sine times sine is sine squared x, right, divided by cosine x. And look at that, we have common denominators. So now we combine the numerators, right? 1 minus sine squared x. So combine fractions here. Just do what you were taught back in grade school again. There's a lot of grade school math, believe it or not. So 1 minus sine squared x, all divided by the common denominator, which is cosine x. And guess what? We've seen this before. We know the Pythagorean identity. Cosine squared x plus sine squared x is equal to 1. That means cosine squared x is equal to 1 minus sine squared x. This is the Pythagorean identity. So the numerator here, this right here, is the same thing as cosine squared x. Okay, so I'm just simplifying here. Numerator stays the same. All right, so I use my Pythagorean identity right here. All right, this is from the Pythagorean identity that we talked about in the beginning of the lesson. Okay, so I use the Pythagorean identity here. And now cosine squared x divided by x, well, that's kind of like x squared divided by x is x right here. One of the cosines cancels, and you just get cosine x. And that, my friends, is called simplifying. All right? Simplify. You get a very, very simple expression in terms of one function only. And that's just, this is just an exercise to get you guys to know your identities. That's all it's for. Later on, if we set this equal to a ratio, we could maybe solve an equation. But right now, we just have to get used to our identities. Okay? Now, this right here, you just multiply. And guess what? This is a difference of squares. A minus b times a plus b is the a squared minus b squared that you saw earlier. It's called a difference of squares that you saw in Algebra 1. Okay? And then so all you have to do is multiply them. And you could use FOIL if you want. Okay, distributive property, which is the same thing. Okay, so if you multiply out, you get 1 squared minus sine squared x, which is 1 minus sine squared x. And as I just said earlier, that's equal to cosine squared x. And you're done. All right, that is the Pythagorean identity right there that I just talked about earlier, right above. Look at the top right of the screen. So you really have to know that Pythagorean identity because it comes up a lot, okay? And so you got to have it. You have to know the different forms, what it looks like. That's why I went into all the different variations. Some teachers don't teach that, and then it's really hard to see visually, all right? In my opinion, though, you have to teach it, go through all the variations that I talked about in the very beginning, and I'm talking about all of these right through here. Because if you don't know what all the variations look like and you don't know where they come from, it's kind of hard to work with them. All right, so practice your variations. Actually derive all that stuff by yourself. And then when you get to this kind of thing, where you have to simplify things or prove things, then it's doable. Okay, so one more time. You have to rewrite in terms of sine and cosine. So rewrite in terms of sine and cosine. Okay, so here we go. It's going to be a complex fraction, but don't worry about it. So sine x divided by cosine x plus cotangent, which is cosine x divided by sine x, all divided by secant x, which is 1 divided by cosine squared x. And yeah, it looks gnarly, but it's okay. And if you're in class here, I'm going to show you how to combine these top fractions real easily here. I call it the 3 product rule. So you take sine, you multiply 3 times, okay? So you go first product, second product, third product. Okay, so sine times sine is sine squared x. Cosine times cosine is cosine squared x. And then if you multiply the denominators, you get cosine x times sine x, all divided by 1 divided by cosine squared x. And it looks gnarly, right? But take a look at it, and the numerator up here is screaming at you. It says, who am I? Okay, and this right here is your Pythagorean identity. Okay, identity, it's equal to 1. So up top we have 1, and then we have cosine x times sine x, and this we're multiplying, or excuse me, dividing by this fraction called 1 over cosine squared x. So now what you want to do is you want to take the numerator, which is 1 over cosine x times sine x, and you want to multiply by the reciprocal of the fraction, 1 over cosine squared x, which is just cosine squared x. You multiply by the reciprocal. So let's write that down. Multiply by the reciprocal. Okay, and the reciprocal of this fraction right here, I'm talking about this one, is just cosine squared x. Simple. All right, and then you cancel out the terms. All right, one of these cancels out with one of these. All right, and you get one of the cosine functions up top divided by the sine of x function, which is the cotangent function. So this whole thing gets simplified to cotangent x. And again, this stuff takes practice, right? So before you even do the next set of examples right through here, you should pause the video and practice this stuff, because if you're just copying notes here without understanding, then you're going way too fast, and because I go a little too fast because I know the stuff, and you gotta pause the video and then practice and then move on, or rewind it and then try to digest it, because going too fast and just taking notes is not going to help you at all. You got to be able to do this on your own. So do what I do in school, or when I was in school, and I would take the examples that my instructor gave me, like this one, right, and I would practice it on my own before I even did my homework. All right, because I knew that I couldn't even do examples 4, 5, and 6 if I don't even understand these. So pause the video and go ahead and do that. All right, this is the end of part 1. I'm going to start the part 2 video here. We'll do some more simplifying, and then we'll also get into some proofs. Okay, and then we'll go from there. All right, so end of part 1 here. And like I said, practice, and then I will see you in my second part of the 7.5 video, part 2, where I do a little bit more simplifying, and then I'll get into some proofs. All right, this is Mr. Aynesworth here. Hopefully that helped you out. All right, learning how to work with the Pythagorean identities here, and a bunch of other trigonometric stuff, okay? All right, I will see you in my next lesson in the video, or I'll hopefully see you in class. Take care. Bye-bye.